So real quick, the college project that you guys started on Friday, don't really worry about that for right now because we have a test tomorrow, so we'll let you kind of focus on that. But then after the test tomorrow, you can definitely jump on Schoology and open up that worksheet if you haven't already started that and start working that. You will get a work day on Wednesday to be able to do some pieces with that as well. But for right now, just don't worry about that because we're going to focus on our test tomorrow and going over like long run values because that was way back on Thursday that we talked about some pieces like that. So why doesn't everybody open up to Schoology and open up the notes for today? And I'll give you a second to do that. So we're going to start with this first one here. If you can do this first one, then awesome. You'll basically be able to do 95 to 90% of what's going to be on the test. So I'm going to give you a couple of minutes here. Just take a look at this problem and go through and do the different pieces. If you have a question about it, just basically leave it blank. We'll go through each of these answers here in just a little bit, get some clarification on them. So why don't you go and take a look. The one thing that I do want to point out is let's see here. Is this piece right here. I added this in here because I think it's a little bit of an important concept that I want to be sure and kind of double hit there. So that's actually not on your worksheet, but be sure and answer that question as well with that one. Yes?
This might be the same length as last test, like a front and back.
Yeah, this will be a Marzano style, so it'll be R2s and R3s, and then the R4s. So take a second and look at this problem here, and go from there. Right here. So let's go through and hit all of our easy points. I saw most people getting most of these right, so let's start here. Is this a loan or is this an investment?
Loan.
It's a loan. Why is it a loan? Because of the subtraction or losing, or basically paying money in. Exactly. What is the annual percent rate? 5.5. And is it 5.5 divided by 12? Exactly. It's 5.5% because this piece here is your annual interest rate, not this whole piece. Don't take that whole piece. Payment or deposit amount, what's that? $25. Why is it $25? Because that's this number right here, because that's the amount that's being paid in or deposited. What's the principal amount? What's the principal amount? $350. Because that is our starting value. Awesome. This first part is going great. That's what most people can do. So that's good. How much is still owed or owned? In our case, it's owed because it's a loan. How much is owed at u is equal to 6? So what do people get for how much is owed at u is equal to 6?
I got
$208.01. Did anybody else get the same thing or a different number? Same thing? Same thing? Raise hands. Awesome. Yes, $208. And then my second piece is, what does u of 6 represent? What does that represent? If I said, what is u of 6 in actual terms? Yes. It's 6 months. This would be referred to as 6 months. Because the sixth piece would be the 6 months. So after 6 months of paying $25, we still owe that amount. That amount. So what does u of 6 mean in terms of time? Months. It's a similar question, but I wanted to be sure and kind of double hit it there because I think it's important. What would happen if this number here was a 4? Quarterly. So then what does u of 6 represent then? 6 quarters or 1.5 years. Yep, exactly. Awesome. So when would this be paid off? When would this loan be paid off? 15 months. Is it between 14 and 15 months that would be paid off? No, it's not. When we're talking about things being paid off, even though it looks like it, you don't know when that payment is. So what if that payment was like for example, my cell phone bill? comes through on the 29th of the month. So I can't know for sure which day that payment is coming through on, and so because I can't say with certainty that at 14 months is, I can maybe take a guess, but I'm just not sure when that payment is actually coming through on that 14th month. So if it came through on like the first day of the 14th month, well then it could probably be there, but we don't know that. So with the potential to have it be a very late payment date, you want to go with the number that you know for sure when it's going to be paid off, and we know for sure it gets negative at 15 months. So we want to be sure and hit that. I had I had a bunch of people, maybe like 10 or 15, maybe not that many, but like 10 do the between months things here. So I'm just really trying to hammer that in here, that we definitely want to be sure and say when it is actually paid off, not necessarily these floating time frames. Was there a question down front here?
Yeah.
Yes.
I don't understand why we put it first.
Yeah. Sure. So this is basically an arbitrary number that you can choose. So we usually do 0 because with monthly, it's easier then to say, hey, my starting monthly before I make any payments is at 0, because then after the first month, I can type in 1 and find out that at month 1, I've done this. At month 2, I've done this. But you could say U of 2, but then you just have to know that at month 1, you're actually going to 3 then to define that. So this is just an arbitrary number that we're choosing, and we're choosing 0 because it usually helps us out.
So when would we change that to like 2015 or 2000?
Yeah. So in our previous, when we were doing more of our annual interest, that's more of when we would change it to years. During this section with loans and investments, when you're doing things quarterly or monthly or different pieces like that, we so far have not even used one that hasn't been a 0, just because it's easier to figure that stuff out. Because if I said, U of 1989, well then I have to know, okay, but this is in months, so I need to find 2001 would then be 1990, because I need to add 12 months onto that. Does that kind of make sense?
Yeah.
So yeah, so just in this section, the simple solution is it's basically always going to be U of 0. So, but that's just an arbitrary number that's being chosen, and you can set it to anything. It just makes our life easier to set it at 0. All right. So moving forward here, this is the one that's catching lots of people, and that's okay because we just had the one day of it on Thursday there. So what is the long run value with this equation here? Or it should say, does it have a long run value? I heard a response. Who thinks no? Who thinks it doesn't have a long run value? Who thinks it does have a long run value? So real quick, to do a review, there's only one special situation when there's a plus sign in the middle that it has a long run value, and that's if the interest is the exact same rate as what's being pulled out. And that's the only time. Every other time when you're talking about a long run value, it has to be a negative. It has to be a negative in the middle of this equation for it to even potentially have a long run. And just because it has a negative, it doesn't mean that it does. So there's still a little bit of guess and check work that you have to do with long run values, but your very first indicator should always be, is it decaying? And if it's decaying, then it has the potential to. Yes?
Can you go over an example of what has like a negative in the middle that it does, but it doesn't belong? It doesn't have a long run.
Sure. So it'd be one like this. That there wouldn't have a long run value because there's nothing that's out here that's basically counteracting it. Because basically what's happening here with this graph is you've got something that is let's see, I have to think about this. So 0.95. So it's probably dropping. It should be dropping like that, and basically just just basically getting smaller and smaller. But if there's something that is counteracting it, that's kind of starting to push it back up and kind of push it back towards zero, that's where you'll see that long run value go there. Well, and actually, you know what? The more that I think about this one here actually would have a long run value. Now that I think about it, because be, be, because eventually, if you get a number small enough and you're just taking 95% of a small enough number, it's going to eventually eclipse and go to zero. So this is a bad example here. You will have a couple of long run values. I'll show you a pre-made example here of a long run value that basically doesn't end up dying out. So yes.
Wait, so it's totally possible to subtract like here in the parentheses 1 minus 0.055
Mm-hmm.
by 12.
Mm-hmm.
And then when you do that to x, like you like
So I said it's possible to subtract 0.055 divided by 12.
yeah, and it's x and x.
Yep. Yes. This is a good point. Thank you. It's totally possible to do this algebra and find out what the long run value would be on this. But if we plug this into our calculator and look, it's not ever gonna stop at that value. It's basically just gonna keep going negative. So it's possible to do our little trick to find long run values when the long run value doesn't exist. And that's why we need to know how to identify problems that have long run values, which ones that don't have long run values. Yes.
When you like if you scroll down,
Mm-hmm.
like you know that's 1 minus 0.0555 by 12.
Yeah.
How would you do that? Like, would you take would you divide 0.055 divided by 12 and then subtract that by 1?
Mm-hmm.
Okay.
Yep. You would just do this math like normal here. So you take 0.055 divided by 12 and get that number. Let's just say it's 0.99, and then 1 minus 0.99, so you end up with 0.01 multiplied by x, and then solving from there like normal. Yes. Yes.
So you just said though that it would work for long run values, like, but I think that the rule was like that plus would be no. How do you know if like will work for you?
So basically, my example that I just showed for Reagan there was a long run value, but the key thing is basically this minus sign. It needs to have that decay to be a long run value. There's one special case where when the interest percent that it's growing and the amount that you're taking out is the exact same, and then it's just a flat line, that there's a plus there. But we aren't going to see anything like that. The simple answer is this: if there's a negative in the middle, it's an indicator that there could be a long run value in that equation. Does that kind of answer your question, or is that not going down the road that you're thinking?
Like I got that, but then you just said that this actually is the long run value.
Right, but the example that I did was a decay.
Oh, okay.
Yep. The example that I did was a decay. So, yes.
To be a long like a number outside the parentheses.
You don't, cause as I just said, with this one here, that actually would have a long run value there, because it's eventually going to push itself towards zero. Because if I just take a smaller and smaller amount of something, eventually that's going to die out, and go towards zero. So let's actually do a long run value one, but I'll take one more question. So it's a little bit of a guess and check approach. You'll have to plug it in and just see if it dies, and then if it does die, then basically use your algebra to figure out what that value is. I would do it through the table. Yep. Yes, sir.
So if it reaches 0, it has long run value.
If it flatlines at 0, if it just reaches and crosses it, then it doesn't necessarily. But if it does something like this where it's flatlining, where basically your table values. Do you remember on Thursday where we found that it was going towards 32? I think was our number, and it just kept getting closer and closer and closer to 32, to a point where the calculator didn't even want to say more decimal places because it's so close towards that. That's the same concept, but we're just saying that it's 0 instead of 32. If it flatlines, it's a long run value. It doesn't matter where it flatlines. It could flatline at 6,000. It could flatline at 0. It could flatline at negative 6,000. But just so long as it eventually goes to where it's basically going towards an asymptote, that's where you're going to get that long run value. We're going to do one of these right now here. So was there a question back there too? Okay, sounds good. So let's jump all the way down here to, I believe it is this one. So this is slide 8 of the notes here. Finding the long run value. So why don't you take a look at this, and let's first set up the recursive rule, and then we'll go from there and find the long run value. Because I think that most people understand how to find the long run value. It's just identifying when it is a long run. So I'm starting with $2,000 in my checking account. Say I'm spending 5% of my bank account annually, but compounded each month. So it's being compounded each month, and I'm adding $500 a month. I don't like the wording on this. Let's say this is something like, hey, my grandparents are giving me $500 a month into my checking account, because it would be weird for you to spend the money and then just put it right back into your account. So we'll just say that it's like your grandparents or some other benefactor is basically inputting $500 a month into your account. What is the long run value in my checking account? So we'll start with our U of 0 is equal to 2,000. Of course, our N is greater than or equal to 1. But this type of stuff doesn't really matter for us when finding long run value. We don't really care about this, but it's good to have in there. So then from there, we're doing our U of N is equal to U of N minus 1 multiplied by, and the reason I'm doing this is because I'm pretty sure that everybody is doing this really, really nicely. So, all right, so U of N is equal to U of N minus 1 times by 1, and then it's the annual rate is 5%. Oops, I'm spending 5%. Spending 5. But it's compounded monthly, so I'm dividing that by 12, and I'm getting $500 a month from a benefactor. So then from here, this is your equation. Why doesn't everybody figure out what the long run value is on this guy? Pause the video. All right, so what do people get for the long run value? What do we get for the long run value of this problem here? I guess I should ask, what's our first step in identifying what the long run value is with this problem? So let's jump back here. So do you remember on Thursday when I was showing you graphs that look something like this? We're eventually flatlining and going on forever there. And I was saying that the difference between this point and this point is essentially nothing. They're basically the exact same point. So if we call this point U of N and this point U of N minus 1, it's kind of like saying that the difference between, my example was, if I have $1 billion and you say that you have $1,000,002, everybody would look at that and say that's basically the same thing. That's the same concept as what we're doing here. So if this is then U of N and this is U of N minus 1, we're basically saying that U of N is equal to U of N minus 1. And since they're equal, we're just going to call that one thing X. So jumping back to our problem here, all that we're doing is we're replacing U of N and U of N minus 1 with an X. And then solving from there. And this one is a little bit of a nasty one because the rounding gets weird. So this decimal equivalent, if I remember right, it's like 0.99583. Is that what people are getting for this for this decimal here? So 1 minus 0.05 divided by 12. What do we get for that decimal there? For this decimal right here, 1 minus 0.05 divided by 12.
Yeah,
996, and then it's like 83 or something like that.
well, I counted it as 2 6.
Okay.
0.99.
Why don't you give me the the full decimal there until the repeating, and then I'll go from there. Yes. 3 repeating. Okay, so then we'll chop it off at 3 then. And there's a reason why I'm doing this, and I'll show it to you here in just a second. So if this is what our decimal equivalent is, we're multiplying that by x, and we're putting this is equal to x, where we're just dropping these terms down, and then we're adding 500. So then when we subtract this off here, so we subtract the smaller one into the larger one. So we're subtracting 0.99583x from both sides. We're getting 1.00527x is equal to 500. Because all they were doing is we're subtracting off this side and moving it to this side to combine our x's. And then we're dividing this. And we're left with x is equal to, I believe it was like 120,000, if I remember right. Yes, sir. But it's compounded each month. Yep. Good. Good point of reference though to check and make sure. Yep, that's a good thing to check out. So it's about 120,000. Now let's say that we round this to a different decimal. Let's say that they were really bad at rounding, and we round this off to 0.99. So if we round this off to 0.99, and we're now saying that, and this is showing the reason why I wanted the full decimal. So if we round this off to 0.99x plus 500 is equal to x, we subtract our 0.99 from both sides. 0.01x is equal to 500 x, and then dividing by 0.01, x is then equal to 50,000. Now that's a difference that matters. 50,000 versus our previous one of 120. So this is why you want to be sure and grab as many decimal places as possible when it's a small value like that, because that, when it's then going back through and dividing out onto the other side, that's definitely gonna impact your numbers overall. Yes.
I found that if you just keep on using fractions instead of decimals, it will come out easier.
Yep. And fractions is another good way to get to that too, because fractions, of course, don't ever need to be rounded off because they are that number. Yep. So so hanging out in fractions can definitely work too. Yep. That's another good option there. But just be sure that if you are using decimals, to get as many as possible, so that you can get as accurate a representation there. And that will be something that you want to pay attention to for the test tomorrow. Yes. Hmm? Yeah. I mean, it'll always, well, this is a little bit of a nasty one because it's so close to 0 that it's at that small decimal change blows up your numbers. There's not one like that on the test where it's so close that you have to be this exacting in rounding. But I just wanted to show this example because it does do a good job of showing why keeping in fractions or doing decimals and getting as many decimal places as possible matters. So yes, Alexa.
So this is the long-term value.
Yes. So then, So the reason why you would know is that one, I would plug it into my calculator and just look a little bit and see to make sure. Like I said, there's not a great way to just look at something and know this is a long run value. So there is some amount of kind of like plugging it in and checking it out and looking. Um, but your first indicator to help you narrow those down should be if it's a decay. Yes.
Like, how do we do that? 'Cause I thought it was a calculator and check.
Yeah.
And like, I thought it was like one
And it just broke it. Once again, it'll be simpler on your calculator. This. Yes. Yep. This is a nasty one because it is, the long run value here is 120,000. Based off of a starting value of $2,000. So that's probably like end of 1,000. It's something huge. Uh, this is a little bit of a nasty one. But it's the example that we had for the long run value. So I want to be sure and go through long run because that's for sure where most of the questions are coming is from long run. Really, it comes down to this. Step one is seeing if it's a decay. If it's a decay, we have a potential. Step two is basically doing a little bit of guess and checks. So just basically plug it in, check a few digits, see does it seem like it's starting to level off? Does it seem like it's not? Can go out to something like 50 or 20 or something like that, just to see if it looks like it is leveling off. If it is, then it's simple. Everybody is getting this part right. The algebra. Algebra. Nice. Then it's just the plugging in of x's and solve it. So I don't love this step. It's annoying, but sometimes we don't know. Like just being honest, like sometimes there just isn't an awesome way to just look and see and tell and make it easy. All right. So let's do this. Take a look at what else I want to be sure and hit with the notes here. Let's see. Got that. Got long run. Got that. Let's go back and grab one of these here. So same idea here. So this is our second equation or actually this is what I wanted you to hit. So this one you don't have in your notes. This one that I added, but just take a minute and look at this and say, what's wrong with this equation? Is there something wrong with this equation? Give you guys about 30 seconds here to take a look at that. All right, so come back in. Does anybody have any ideas about what could be wrong? I got one idea, but I'm going to wait for a couple more. Who thinks that they have an idea of what might be wrong with this? Got 3, 4 maybe? Give you another 30 seconds. All right, so what do we think is wrong with this one? I think it's our Will's hand first.
The interest is really high. It would be 17%.
Mm-hmm. Yeah, this is a crazy high interest. It probably just means that you took out a really bad loan, but that's not necessarily wrong, but that is an indicator of something. Yes. It does have to do with that. Do you have more ideas? It's never going to hit zero. Because this interest rate is so high, and because this amount isn't going to at least eclipse that interest rate, this is a loan that's never going to hit zero. That 100 would need to be a lot higher. Yep. Yes. Good job. So yeah, that's this is something that you might see, and just take a look for that stuff. Watch and see if, and remember, like, hey, is this a loan or is this interest? And once I plug it in and look, and it's growing and it's a loan, So something's wrong there because we want loans to be going down and decreasing towards 0. All right, that was a little bit of a tricky one, but I like that one. So let's jump down here to number 4, and we're doing a similar thing. We're also going to get, I believe this one does work out to have a long run value. So, but you can check me on that. So why don't you take a second and do this next one? Similar stuff there, and I'm going to add one more piece into this here at the end. All right, you're not quite done here. I got 2 more things that I want to hit, and this is one of them. So we'll just keep moving here. 1, is this a loan or investment? Investment. And how do we know? Yeah, it's a little bit of a weird one because of this. This is a bad investment because you're putting it into something that's losing, but technically it is an investment. What's the annual percent rate? 7.5. Awesome. We know that because of this. What's the payment or deposit amount? So since it's a deposit, so it's $25. Our principal would be 1,000. How much is still owned, or how much is still owned at U of 6? What do we get for U of 6? 1,110. Did I hear? 1,110.76. All right. 1,110. Okay, thank you. 1,110.76. Thank you. All right. What's that? Yes, I would. Thank you. Okay. We did these guys, so I'll jump past them here. Or no, we do want this one. When would this loan be paid off? Did anybody get when this would be paid off? Or investment? Yeah. So this one here wouldn't be part of it because it's not part of the because it's the investment. And then did anybody get a long run value for this one? Yeah. What do we get for a long run value? Here's some mumbling. Yes. 4,000. Does anybody else agree that it's 4,000? Yes, and that's just, we're just going and we're plugging in our x's here and solving for that. And you can leave that as a fraction, or you can do the decimal, but just be sure and keep them. So, yes, good. That's good. Let's actually jump back to our first example here, because I want to do one more thing with this here. Or actually, before we do that, let's stay here. So remember how we were running into this issue with plugging it into our calculator through the finance app, and it was being weird, and we couldn't figure it out for a couple of days. Well, here's what we figured out. So instead of looking at it graphically, as far as like, hey, our present value, whether that's a negative number, and then we're moving it to a positive number, we're thinking of it in a little bit of a different light, and we're thinking about this as what money is going into our checkbook or our pocket, and what money's coming out of our pocket. So what we've kind of come up with is that that basically your present value. So let's say with this one that we're doing this investment. Well, to do an investment, you would need to pay into this account. So basically, out of your pocket into this account, this initial value, which I think was $1,000. Yes. So this one here, we would actually want to have this be negative 1,000, and the reason why is because we're paying into this account, we're paying out of our pocket into this account $1,000. Then our payment, you'd also want that to be negative, because once again, each month, if it's each month, you would be paying this $25 there. So once again, that's money that's coming out of your pocket. The interest value is actually not negative in the way that we're thinking about it here. You would keep that interest value positive. So this is it's not actually losing. I I I personally don't love how this thing is kind of thinking and going because it's a little bit different than basically how my brain works. But this is the way that that makes the most sense. So this is actually growing this investment, which is why it's which is the investment in this case is actually growing because investments are basically always growing, and that's the piece that's weird about it and why it threw us off. Oh yeah, in this problem, you're right, Trent. Yeah, this is a weird investment one that's a negative investment, which would never happen. So yes, sorry about that, Trent. Yes, this is in this weird problem. This is a negative investment. So then you would have that negative 7.5%.
There are quite a few banks that now have negative interest rates, like
Yeah.
Japan and Sweden and Switzerland.
Oh yeah.
They all have negative interest rates.
Well, there's your negative interest rate and reasons why you should invest in other things than just leaving it in the bank. So, but yes, Trent, thank you for pointing that out in this weird problem. Most investment problems that'll be a positive percentage there because you want your money to be growing, but when this weird one here, it is going negative. Yes.
So if it was a positive, it wouldn't have a long run, right?
If it was a positive value, then it wouldn't have a long run value. Correct. Yep. Yes.
Investments have a positive.
Yes. If you're investing in something that's negative, that would be called not a good investment because it's just yeah. Yep. That's like cars. Like cars are nice because they get you places, but overall they depreciate in value, and so overall, like in theory, cars are not a good money investment because they lose value.
What about anti-cars?
What it asks.
Depends on the car. Please, even those will lose value. Yes.
So even on the test, oh, this is investment. Normally, it's positive. Normally, investments don't have long-term values.
Normally, investments do not have long-run values. Yeah, this is a weird example, and I don't really love it. That this is an investment that is declining on your test. If it's an investment, I don't think there's a single investment that is declining. So, yep. But yeah, just the key thing is this. Just think about this as what's coming out of my pocket and being paid. So if this is a loan, let's say that the same numbers here that this is a loan, you would then be saying that let's say that's 7.5% or 5.5 in this case. So it's a new problem. If it's a loan, the bank is paying you, $1,000. They're basically loaning you $1,000, and so that's why then with a loan we end up doing a positive value here, but then what's coming out of our pocket each month is that payment all of $25 going back into it there. Yes.
The key because the parents here have to do what you think about it with your bank account.
Yes.
The key is what you ask, what's going into it.
This the way that we're trying to structure this and think about this is as far as what's coming out of your pocket, and like I said, I don't necessarily love that thought process, especially since we started down the other trail. But this is the way that basically this thing thinks and kind of works. It's basically kind of like learning a new computer thing or a new computer program. You have to kind of learn how it's thinking and what it's trying to do before you can go and tell it what to do. So the key thing is this: is if it's a loan, the bank is giving you money, you're just spending that money, and so in theory, the bank is giving you that $1,000, so it's a positive. But then each payment is coming out of your pocket and going back to the bank, so that's a negative. If it's an investment, you're paying into this account, and then you're paying into this account each month as well. So it's basically two negatives on the investment, one negative on the loan. I had a couple of questions here. Before I hit those questions, there's a quiz on Schoology. That's going to be your homework for the evening. It's not a matter of how many you get right. It's just a matter of if you do it. So that's going to be the homework for this evening. I'll grab in just a second here.